Hello, I'm Incremental, and this work is being supported in part by National Science Foundation and First, let me ask you a question. How much time or how much effort do you spend on testing when you write code or when you write programs? How much time do you spend?
Well, honestly?
Well, it may depend on individual programmers or the kind of or the type of programs that you are writing. I have some interesting studies. For example, first, testing is the most popular way of assuring the correctness. I'll say that actually it's the de facto industrial standard way of showing that your program is correct, right? Your program behaves as expected. However, testing is very labor intensive, it's time consuming, error prone, and costly. For example, they did some study in 2002 by National Institute of Standard and Technology. They said that typically we spend 30% to 9% of development cost or effort for just doing testing. Okay? And also in the same study they said that in 1999 they spent, in the United States alone, they spent $60 billion just for testing. That's outrageous, I mean. And also I heard that in Microsoft they have one tester for each programmer. Not for the testing phases. From the beginning of the project. When you start project, for each programmer they assign one tester, which is very costly. Okay? It's outrageous. I mean, by definition, what is testing? Well, it doesn't add any functionality, right? It doesn't add any features. It doesn't improve the performance. It's just we want to make sure that our program is correct. And we spend 9% of our development effort. Okay? So the question that I'm going to bring today, and hopefully try to answer is, can testing be cost effective? Okay? One way, you automate it. Okay? Here I'm going to propose an approach that we can achieve nearly 100% automation. Basically, I want to just click the button, and then my program, my tool magically perform testing from the start to the end. That's the goal. So this is the outline of my talk. Okay, I'm going to focus on the unit testing because I'm interested in program level testing. Typically, unit testing is done by individual programmer. Okay, and also it's a foundation for all other kind of testing, such as integration testing, system testing, and that's why I'm focusing on unit testing. And then I'm going to explain my approach of test automation. Okay, especially I'm focusing on the test oracle. Basically, once you test, you have to decide test result. This is called test oracle problem. Okay, and then another important topic is how we generate test data. Because by definition, testing means you run the program. To run the program, you have to supply input. Okay. And then I will share some of my results and then current research. And we also have prototype tool. And I will give a quick demo on our prototype tool called Sage.
You pose a challenge that we're putting these on the web. And you're posing a challenge that nobody has previously given us, which is that you jump around. I'm going to move further back. That's all.
Okay, so
Didn't engineer for this.
Well, unit testing is a module separately or in isolation. For example, it can be a class or a set of classes that work together. Or it can be a procedure or method, depending on your programming language. And this is sort of foundation of all other kind of testing because it doesn't make sense to do integration testing until you finish unit testing. Okay? Now, whether you do unit testing or some other testing, there are several steps or activities that you have to do. But these are sort of key activities or steps that you have to perform to do testing. First, you have to generate test data. You have to select test data because you are going to run your program, right? And then you actually run the program that you want to test by supplying the test data, which is called test execution. And then once test execution done, you have to decide test result, test outcome, whether test succeed or test fails. Okay? I'm going to propose a solution that automates each step of this. But mainly I'm going to focus on test data selection.
This is very good for our TAs who test the students' programs, right?
Yeah, you can use Incremental. That's free. All right? So now, let's look at a small example to set the context in the unit testing of Java classes. Imagine that you have this class, bank account. It's a balance. I have one method called transfer. According to the Java log, it says that the method transfers some amount from one account to another account, the receiver object, right? Now, to test this one, what the test data or test case looks like? Well, you run the program, right? To call the transfer method to test it, you have to supply the argument amount, some int value, account, some account object, and also since this is an instance method, you need a receive object to which you send a message transfer, right? So in our framework, each test data or test case consists of tuple of values. The first one perhaps is receiver, the other are arguments, okay? And then sometimes, okay, here's an example of test cases. Okay, the receiver, first argument, second argument. Sometimes when you select test data, the test data you select has to satisfy certain assumptions. For example, the method that you are testing is making. For example, according to the Java doc, the transfer method says it assumes that the argument amount is less than the balance of account, the argument account. So when you select test data, you have to satisfy this set of assumptions. Okay, for example, the first one may be invalid. It's inappropriate to test this one because you are asking to transfer $10 out of an account that has only 5. But according to the Java comment, this one doesn't take that. Right? And also, often it's the case that these assumptions, preconditions, invariants can be specified in executable assertions. For example, Java 1.4 has assert statement. If you use C or C++, they have assert macros. Or there's annotation language that allows you to document the behavior of the module that you are writing. For example, Java model language that I'm working on is such an example assertion or annotation language. So based on the Java comment, it documents the behavior of the code that I'm going to test. For example, here's invariant, which says that balance should be always non-negative. And then here's a present description of what transfer method does. For example, the precondition, which is specified in the required clause, said that argument should be positive and the AMT should be less than account.balance, okay, from which you are transferring. And then assignable clause, which is specified what we call frame action, basically says that this method can only change the balance and balance of argument account, nothing else. And then house condition describes the behavior of this method. Okay? So if you look at first, it said that new balance is the same as all the balance plus the amount that you are transferring. And also, new balance of ACC, argument account, is the same as all the value minus amount that you transferred. Okay? And also I have special annotation that says the argument should not be null. Okay? So this way, you can document the behavior of module that you're testing. Okay? And also these assertions can be checked at runtime. For example, in the other case, we have runtime assertion check. Compiler can compile this into runtime assertion checking code. So what are my approaches? Well, let's first look at test oracle problem, and then let's focus on test case generation. Okay? So how do you automate test decision, the result deciding the outcome of test? Okay, the idea, we are going to use this runtime checkable assertion as test oracles. So for example, imagine that you want to test this method, then basically this is oracle procedure. Okay? Give a test data receiver, amount, and ACC. Basically your oracle performs the testing by calling the transfer method, the target of the method that you are testing, by supplying this test data, and then observe whether there's any assertion violation at runtime. Okay? For example, if there's precondition violation, what does that mean? It means that you have invalid test data because precondition is client obligation. You supply invalid test data, so we therefore invalid test data. If there's no such assertion violation at all, it's test success, right? On the other hand, if we have any other kind of assertion violation, such as post-condition violation, we know that there's inconsistency between your implementation and your code. Your implementation doesn't satisfy conform to your specification, so it's failure. Okay? Any kind of error, it's test success, because maybe originally the program is intended to throw some exceptions. Okay? So this is how we handle test oracle problems. As long as you write executable assertion, you can determine test result automatically. Our tool will generate this oracle procedure. Okay? And then the next big question is, of course, how we generate test data, how we select test data. Okay, again, in our case, test case is a tuple of values, receive and argument. Okay? And the simplest approach is select randomly. Well, first, it doesn't look that promising, but there's an annoying study that says if you consider cost, random testing is the most effective test selection method. There's actual study saying that. Okay, so anyway, let's try to apply it. I guess the reason that random testing is effective and cost effective is that if you do randomly select test data, it eliminates human effectiveness of human tester, because human testers always have the same logic. They tend to think or pick the same test values again and again. Okay, and also by selecting test data randomly, you bring diversity to the test data that you select, and also it can be fully automated. Okay, so how is select test data? Well, basically you pick random values. For example, in the amount case, you know it's 32-bit int. In Java case, we pick arbitrary values. Okay, but next question is, what about this arbitrary account or receiver? It's an object. How do you pick random object? They don't exist, right? You have to construct. So the question is, how do you construct random object? An object of random state. Well, conceptually it's simple, because object is what? It's a tuple of field or attribute. For each attribute you assign random, pick random value. That's concept, but practically not, because this field is hidden, right? Class encapsulates this field. You cannot directly assign to it. So you have to do it indirectly. One way to do it is, first you select some construct randomly to build initial object with initial state, and then hopefully call sequence of methods by hoping that each method call mutate the state, so that you bring some object of intrinsic state so that you can test. Okay? So to do that, we classify the method of a class into several categories. Basic constructor, which creates an initial object; extended constructor, which can create another object, even existing object; and then mutator or command method, which hopefully change the state of object; and all others, observer or accessor, which basically observe. So we don't use observer. Basically, our approach is first create an object and make a sequence of mutation calls. Hopefully, it changes the state. Okay, and you can do this classification based on the signature. For example, command method shouldn't supposed to return any return value. So if some method is void type, we assume it is command or mutation method. Okay? And also you can use JML annotation, because in JML annotation, there's special keyword indicating that this is observer, this is accessor, and so on. Okay? Now we implement this. One thing that we find out, if we apply this, if we pick randomly method constructor, and we find out among the generated test data, 50 to 90% are redundant. Okay? So generating the same data again and again. So to handle this, we introduce a notion of object equivalence among the test data based on the object state. If the class has equal to method, we use the equal to method to compare two objects to know whether these two objects are the sort of redundant data or not. And also, if it doesn't provide equal to method, we compare the whole sequence to determine whether one test data is redundant with respect to other test data. Okay? Now there is another problem of this approach. When you build an object by making sequence of calls, let's call it call sequence. Not all call sequences are feasible, because each method call has to satisfy the precondition, and also it has to terminate normally. Otherwise, if you have a sequence of method calls, if one call fails, the whole sequence fails to produce an object. Right? So how do you handle this? Well, initially we pick all the sequence randomly, and we try to build every object at once. And then we find out the success rate wasn't that good enough. For example, in the transform method, 99% of whole sequence was infeasible. We was not able to build any object. So the second approach that we propose is so-called incremental approach. The idea is we pick one constructor or method call, and then actually run it and check whether we can actually make such a call on the fly at runtime, checking pre and post conditions. Okay? And we also introduce notion of object pooling. Once we build a successful feasible sequence, perhaps we can reuse it by appending new mutation method at the end. Okay? So we support object pooling. And then we did a small evaluation to see whether our approach is effective. And we did mutation testing. Basically, mutation testing is a one way to compare new approach of testing. For example, the way we perform mutation testing, given an existing code, you insert or inject some number of faults and see how many injected faults your approach can detect. So we choose some package which has 9 classes, some number of interface, abstract class, 1,000 lines of source code, and then we mutate by injecting 20 faults manually. And we change some values, one value with another value, we replace one variable with another, one statement with another, and so on. We mutate it, and then we run our program by just clicking a button, and our tool, our approach was able to find 27 mutants. So success rate was 90%, which was good enough. And then the remaining 3, we find out this is what we call equivalent mutant. You change the program in such a way that it behaves the same as original one, so you cannot detect it. So actually, the effectiveness is very good, because we have in fact, we have caught all mutants. Okay. And another finding is that this approach is very effective to do regression testing, because in object-oriented programming language, whenever you introduce a new subclass, potentially you have to test every method that you inherited, right? Because if you override one method, that overriding may change the behavior of all the methods that you inherited. So since tests can be fully automated, we can perform testing as much as you want. Okay? This actually shows the evaluation. For example, we evaluate our approach by using several sample data. This one compares the original, the pure random, which just pick all the sequence randomly and start building the object. And then incremental approach, one whole sequence at a time. And then we find our incremental approach improved 10 to 200% in terms of the number of valid test data that we can generate. And the current research topics, that was the sort of starting point of our research. And then currently I have several students who extend this approach. The main thrust of our research is how we can improve the success rate of generating valid test cases. I have 2 students, and Tony Cortez is trying to combine constraint solving to random testing. The idea is we have very efficient constraint solver for finite domains such as int and float. Perhaps we can generate test data randomly for object. For non-object values such as integer, parameter, and so on, perhaps we can solve the constraint. Then we can improve the success rate. I have preliminary results that I'll show next slide. And then I have another student, Myung Kim. She's trying to apply genetic algorithm. The idea is, initially in our approach, you pick a set of test data randomly. And then if it fails, you pick another set of test data randomly. Okay? In the genetic algorithm idea, instead of throwing it away, perhaps you pick some number of test data which are most likely to succeed. And then we mutate it by applying genetic operator. There is some natural evolution. Okay? And then I have new student, Young Wan, who just started working with me this semester. And he's trying to generate test data based on the requirement. Perhaps the requirement state, you have to test this, this, this. And then how we generate test data, actually construct test data that satisfies this requirement. And also how we take the user's input. For example, when you write the program, the programmer may have, well, for this method, I want to test this test data. So how we can take that input and combine it with random testing. Okay? And this slide shows the result of initial work of combining integrating random testing with constraint. By introducing constraint, we was able to improve the diversity of test data and also success rate, 6 to 13 times, which is huge, 600% or 1,300% of increase. For example, this first diagram shows that if you use our original approach, all the test data is here. But if you use our approach, test data are dispersed. Okay, it improves diversity. And we tried several different ways of incorporating constraint solving. The white bar here denotes incremental random testing. And then the other is combination of random testing plus constraint solving. This is 6 to 13 times improvement. Right? We have a prototype tool based on this idea. I'll show you quickly. I call it JET, Java Evolutionary Testing, but it's not evolved yet. It's still doing random testing. Eventually, I want this to be able to do genetic evolution testing. So anyway, here's my tool, the tool that we developed. So let's take some example classes. Okay, I have a count class that I can call. Let's drag it. Then it shows all the public methods that you can do testing. And then basically you just select a set of methods that you want to test. And also this class is annotated with JML annotations. Okay? Let's test all the methods, choose test all. Then basically what it does, for each method that you want to test, it generates some number of test data printed randomly, and then executes it, and decide test result, test success or test failure. Okay? It's mining test data. Good? So let's see some example. Okay, there's some test failure for transfer method. So if you click transfer method, here's test data that failed. If you click it, you will see the details of the test data. This is actual test data. The receive object that it created, argument values, object, and then it tells you why it's test failure. There's inconsistency between your implementation and perhaps post condition. So if you click the error message, it shows that your test data tried to run it, and it violated this withdraw method, which is, I think, called by transfer method. So that's test failure. Okay? So basically, by just one click, you can automate all the testing, from the test data generation, execution, and result determination. And then you can also export this to unit testing, and then you can add manual test data. Manual test data. Okay? Question?
Well, is this, were you talking to both you and for Steve?
No, I think Steve has gone up 30 minutes. I'm almost done.
No, actually, we have 20 minutes.
Oh, no, this is my last slide.
It's okay.
So in this stuff, I showed you that nearly 100% automation is possible. Okay? And also we find that it's good for regression testing, especially in object-oriented program, because we have to retest all the inherited methods. And then we find out we need more research on feasibility, okay? And how we eliminate redundant test data. The tool that I showed today is available from my webpage. Do you have any questions? Comment?
I have a question. Going back to one of your earliest slides, you don't need to put it up. You showed a case where you had a procedure that implemented something, some function, and then you showed the test code that was embedded in it, and it looked like the test code, or not test code, but what was the
Test oracle?
Yes.
Okay.
That code looked like it was basically re-implementing the algorithm of the procedure. And what I'm wondering about is, does the Oracle specification code end up being of comparable size and complexity and...
Oh, you mean the post condition?
Yes.
This one?
Yeah.
This one?
Yes. Because transfer probably is about the same length as requires and assignable and sure.
Right. That may be true, depending on the method body that you are writing. In this particular case, maybe the spec is more complex than your implementation, because I can just finish my implementation by 2 runs, withdraw and deposit. But if you have to write this code only for the testing purpose, that's too much work. But this is good documentation. Okay?
Couldn't we just run that code instead of the stuff below? It seems like that seems pretty close to something, to the description of the algorithm.
No, the problem is, this one doesn't return or produce actual object that you have to return or produce. Basically, this is condition. Post condition is just assertion, Boolean expression. If you produce a new object or state, I'm going to check whether this predicate holds or not on that state. Okay? And actually, there is a way to actually generate code that satisfies this one. This is not. the focus of this research. But, well,
I'm just wondering how much bloat that creates on the engineering problem, because it's really
well,
writing
ideally,
program twice.
ideally, if you have a Java programmer, before you write this chunk of code, right, you are supposed to write document. You're supposed to know what this procedure or method is supposed to do. You write Java. Okay, so instead of Java, if you write this chunk of assertion, it's precise, maybe it's concise, that is unambiguous. So yeah, that's the assumption. Yeah, that's the assumption. Maybe assume that, well, you can actually generate test data without this one. Okay, if you have a trivial post condition, say instead of this, that's just true, then every test will succeed. The quality of test result depends on the quality of the post condition that you are writing. So if you have some key feature that you want to test, you can only say that one, and then you run the test. Okay, and also this coming up or writing this assertion give more insight about your method or procedure that you have to write. For example, if you have this one, okay, there's some ambiguity, right? This one doesn't say the amount should be positive. But once you start formalizing, you notice that, well, the amount should be positive, and instead of less than, maybe it's okay to be less than equal. And that this is actually good API documentation. Okay? The object orientation is all about reusing. You want to reuse the code without actually looking at the source code. Microsoft doesn't read the source code. You have to reuse it without looking at the source code. So how do you reuse it? You have to know the behavior. One way, you document it. Informal documentation sometimes is okay, but there are some ambiguities. And you can write in position. And also the nice thing about JML is, even if it looks different, but it's basically Java Boolean expression. Okay? Yes.
Once you find errors, how do you know how to fix the program?
Well, this is 99%, 9%. It doesn't tell you how you fix it, but it
Because I'm sure
gives you a
Microsoft
location
receives
of...
millions of reports from people who fix and report. So they know the errors, but they may not know how to fix them.
Right, that's a different, I think this also another to this problem. They're not trying to solve how you fix it. They're trying to detect the potential errors.
So can you contrast this approach of yours with other approaches to detect failures automatically? What is the advantage?
I think our contribution is we try to combine the use of assertion and test automation. Okay, random testing, generating test data random is not new. Many people did that, but our contribution is how we turn the pre and post condition as executable test oracle, and how we automate it by generating test data randomly. And also another contribution that we try to make is how we combine different approaches such as constraint solving, genetic algorithm with random testing. I didn't see any work done in that area yet.
So, thank you.
Thank you.
Yay.